The topic is on germicides. We have to think about disease transmission, disease prevention, and also disease management. In the year 2019, and also year 2020 and year 2021, there was a condition or a disease that was known as COVID-19. This is a disease that affected nearly the whole world, and it was a very serious disease. So one of the things that people were being encouraged to do was to observe good hand hygiene through use of soap and water. And if those two were unavailable, hand sanitizers became very, very important. So hand sanitizers contain germicides. Then when it comes to wound care, sometimes you also use germicides. And an example is povidone iodine. Then when it comes to the surfaces, maybe if you're working in a hospital setting, or even areas that when you want to clean even the floor of some areas, we use disinfectants, and disinfectants are good examples of also germicides. So even in the food industry, yeah, you have to ensure that the surfaces are clean where you're working from, and therefore you are supposed to use germicides. So germicides are very, very important in our society. So welcome to my presentation on germicides. So germicides can actually be covered under very many units. We have pharmacology, we have pharmaceutical chemistry, and many other areas. But the terms that are normally used are just the same. So what are my objectives today? My objective number one is to define germicides. My objective number two is to study antiseptics and disinfectants. My objective number three is to look at sample questions. Let us look at the definition of germicides. We have the general definition, and under that we can define a germicide as a chemical substance or a chemical agent that kills harmful microorganisms. And the examples of these microorganisms that you're talking about include bacteria, viruses, fungi, and other pathogens. Some germicides destroy even spores. Germicides can be used to disinfect surfaces, to sterilize medical equipment, and also to maintain hygiene in various environments. So if you're working in a hospital setting, you may be required to sterilize some medical equipment so that you are able to use them on other patients. If you're working in the food industry, again, it is important for you to maintain hygiene so that you produce food that is not contaminated. Then we have the medical definition of germicides, whereby a germicide is any substance or compound that specifically destroys or inhibits the growth of disease-causing microorganisms. Again, the microorganisms that you're talking about are bacteria, viruses, and even fungi. So, a germicide can be applied on living tissues, and those germicides are referred to as antiseptics. You can use germicides on non-living objects or inanimate surfaces, and those ones are referred to as disinfectants. And the aim is to prevent infection and also contamination. There are these two very, very important terms that you need to know when you are handling or when you are dealing with germicides. And those two terms are Cidal and static. So to summarize, Cidal is just killing. Those agents will kill the microorganisms. But static, the agents which are static actually they just inhibit growth of microorganisms. So we'll start with the first term, which is Cidal. So you can have, for example, you can have bactericidal agents. So Cidal agents kill microorganisms outright. They ensure that they are dead. So the term Cidal comes from that Latin word meaning to kill. So you can have bactericidal agents, fungicidal agents, and even virucidal agents. So the bactericidal agents will kill bacteria. Examples of bacteria, Staphylococcus aureus. Then you can have fungicidal agents and also virucidal agents. Fungicidal kill fungi. Virucidal kill viruses. So these agents work by disrupting key cellular functions. And these include damaging the cell wall, inhibiting the enzyme activity, or even interfering with the vital processes. For example, DNA and RNA replication. So the application, you can have disinfectants, which have Cidal activity, antiseptics, and also sterilization processes. And whatever process, yeah, the aim is to ensure that there is total elimination of harmful pathogens. Then the second term is static. So you can have bacteriostatic agent or even a microbiostatic agent. So static agents inhibit growth or reproduction of microorganisms without necessarily killing them outright. And therefore static, we just come from the word stopping. Yeah? It simply means stopping. So you can have bacteriostatic antiseptics or disinfectants. You can also have fungistatic antiseptics or even disinfectants. You need to remember that static action is considered a preservative action. So we've said that when you see the word Cidal, it means that that agent actually kills. Then when you see the term static, it means that that agent actually inhibits growth of the microorganisms. On this slide, we have examples of antiseptics and also examples of disinfectants. Dettol is an example of an antiseptic and it contains chloroxylenol. Another example of an antiseptic that is shown on this slide is betadine. Betadine contains povidone iodine. Then we have examples of disinfectants. And one of the examples is Lysol. And another example is glutaraldehyde. So we have this next slide, which states that disinfectants and antiseptics are alike, whereby they are both germicidal. So what about antiseptics and disinfectants? These antiseptics, for example, Dettol, they are normally used on living surfaces. So they are chemical agents that are used on living surfaces. What do? They cause destruction or inhibition of growth of microorganisms. It is always important that you get to know what we mean when we talk about microorganisms, and we'll keep mentioning those examples such as bacteria, fungi, viruses, etc. And they cause this destruction on living surfaces such as the skin or even mucous membranes. Examples include povidone iodine, hydrogen peroxide, and also chloroxylenol. For disinfectants, they are chemical agents that are used on land living surfaces or inanimate objects. What do? They cause destruction or inhibition of growth of microorganisms on non-living surfaces, such as the toilet. Yeah, it is always important that you disinfect your toilets. We have the furniture where people sit, rooms, equipment, water supply. Yeah, you can also disinfect your water so that it is fit for drinking. So the examples of compounds that you can use include chlorine and the related compounds. An example of this related or oxo compound is sodium hypochlorite. The other two terms that are important to know, that is sterilization and disinfection. So sterilization is complete killing of all forms of microorganisms, including spores. So you have to ensure that your surface or your instrument is completely free of any microorganism. Completely free of any microorganism. That is the only time you can actually say that your instrument or your equipment is actually sterile. While disinfection is the reduction in the number of viable pathogenic microbes to a level that they do not pose a risk to individuals with normal host defense. So we have the classification of antiseptics and disinfectants. You can have alcohols, for example, ethanol or even isopropyl alcohol. You can also have biguanides, an example being chlorhexidine. You can have the halogens, and under halogens, you can look at iodine. Iodine and chlorine, they are both in group 7. Yeah? So iodine and the related compounds. So you have iodine itself and also povidone iodine. Then you have chlorine itself and the related compounds such as sodium hypochlorite. Then you have the aldehydes, for example, formaldehyde and glutaraldehyde. Then you have phenols, for example, chloroxylenol. Then you have quaternary ammonium compounds, for example, cetrimide. Then you have oxidizing agents, for example, hydrogen peroxide and also potassium permanganate. You have the acids such as boric acid. Then you have metallic salts such as silver nitrate, which is a silver compound. And then the dyes, and an example is gentian violet, commonly known as GV. What are the ideal properties of disinfectants? Number one, a good disinfectant should have a broad spectrum whereby it is able to have a wide antimicrobial spectrum. It can destroy a wide range of microorganisms. Number two, we have fast acting. You want to get the results very fast. So a rapid kill is very, very important. Disinfectants should not be affected by environmental factors. For example, if you have organic matter around you, such as blood, sputum, feces, it should not affect the activity of the disinfectant. Then it should also be compatible with the soaps that you are using or even other detergents. It should be non-toxic. Yeah. You have the user, so it should not harm the user who is maybe the cleaners. It should also not harm the patient. Then you have surface compatibility, whereby it should not corrode instruments and metallic surfaces. And it should not also cause deterioration of cloth and even rubber. So the choice of disinfectants actually can also be determined by the type of surface or the type of material that you are working with. Then it should have the residual effect on treated surfaces, whereby we want it to have it should leave an antimicrobial film on the treated surface. This is a continuation of the ideal properties. Should be odorless. Yeah, you just want it to have a pleasant color. Or if it doesn't have a pleasant odor, it should not have no odor, so that you are able to use it routinely. It should be economical, and here you are looking at cost. So it should not have a very high cost, because that high cost will be prohibitive. It should be soluble in water. Then it should be stable in concentrates, while concentrated, and also in use, that is after dilution. Then it should have good cleaning properties. Last but not least, it should be environmentally friendly, and therefore it should not damage the environment on disposal. So my last objective was to look at the sample questions. And question number one that you can actually get is, what is the difference between antiseptics and disinfectants? What is the use of a disinfectant? Then what is the difference between disinfection and sterilization? And then what are the 6 types of disinfectants? And then last but not least, we have what are the ideal properties of disinfectants. So I'm going to have part 2 of antiseptics and disinfectants. So be on the lookout. Thank you.